Hello everyone. Today we are going to discuss the comparison between the three BJT amplifier. Okay, so there are three configurations in a BJT, that is common emitter, common base, and common collector. So we will see that where the input is connected to in each of them, where the output is connected to, and the voltage gain basically, and the phase shift between the input and output. So these all things we will observe in LTspice, and then only we can fill this table. So let us directly start with the simulation. Okay, let me reduce the size of this window over here. Close this. Okay, I guess, yeah. So this is my common emitter amplifier using BJT. Let me just reduce the font. Yeah. So in a common emitter amplifier, what we can say that the input is applied to the base and the output is taken from the collector terminal. So these are the 2 points. The third point is the voltage gain and the phase shift between input and output. I'll quickly run this and show it to you. Okay, what is the phase shift between the input and output? So as you can see over here, the phase shift between input and output is quite clear. It's out of phase. Okay, so it's clearly out of phase, and we can check this number also now. I will put some wire over here. Normally, CE amplifier is providing a very high gain for that matter. Yeah, see like this. So that's the output. Now you will be wondering why input is almost a straight line. Input is not a straight line. Basically, its value, magnitude is very small. So what we can do is right click, add plane plot, and pick the input out upwards. So that's how we can do it. V in and V out separately. As you can see, they are almost 180-degree phase shift apart, and the highest value it's around, let's say over here, 2 point, yeah, 2.08, and the lowest value is of the output is something like this. So 4.52 divided by how much it is, 20 millivolt. So I'll use a calculator and just check it. 4.523 divided by 20 millivolt. So 4.523 divided by 20 millivolt. So I'm getting an answer of around 226, and theoretically it's 241. Basically that's what we have written, and but practically we are getting around 226. That's quite high actually. So this is good. I mean, we can have a configurations BJTs which can having a higher gain than this also. So that's what we observe, and why there is a phase shift of 180-degree, it's clearly visible over here. They are out of phase with each other. Okay, now let's concentrate on the next part. So next we have common base. So let us close this. Yes, save. So for the common base configuration, as the voltage divider biasing technique remains the same, only thing is input is applied to the emitter for the common base configuration. And here I think there is some mistake. Input is applied to the emitter, and output is taken from the collector. So I think these two are interchanged basically. So the input is connected to the, I repeat, input is connected to the emitter, and the output is taken from the collector terminal. So that's what I thought. So I think it's a mistake over here. These are interchanged. So if you write emitter up and collector down, it will be proper. Okay, again for the common base configuration, we will quickly simulate the circuit and check whether we are getting the desired results or not. So this is my common base configuration, my input. Just let me just adjust this. Yeah, for common collector we will see later, but for common base, right click, add trace, V in and V out. Yeah, so these are the waveforms which we are getting for common base. Now one thing to note over here is if I divide it into two planes, like this. So here the input is 10 millivolts peak to peak, and the output is close to around 1 volt, 2 volt peak to peak. As you can see, very clear, distinct feature that they are in phase with each other. There is no phase difference between the input and the output waveform in case of common base configuration. Now let's go to common collector. Now in a common collector, we have applied the base as the input terminal and emitter as the output. Output is taken from the emitter terminal, and it's a voltage follower. So its voltage gain cannot be more than one. It's actually unity, very close to unity. Less than that will do, but not very close. Very small. Okay. So for the BJT, common collector amplifier, these are the this is the diagram, and here we have to check whether the output is giving less than almost equal to one value or no. So again, I go to simulate. I'll click on run, and then this is input, and that's the output. So if you see carefully, okay, I have to add it again. V in, I have to individually plot, I guess. Yeah, I think it was getting only the output was coming properly. Some mistake might be there, not a problem. We can divide it into two planes and push the output up, and the input is down. Now as you can see, they are in phase with each other, and actually the output is slightly less than the input. If you can check them together. Let me just show it to you. Yeah, see, if you see clearly over here, they are almost matching, but for a small interval of time, as you can see, slightly deviating. So they are almost the same only, whatever we are doing. Okay, now let me just delete this pane plot and come back over here. So that's how we can check. And now let's quickly check the output amplitude. So output amplitude is peak to peak. So here it is this peak, and one more peak will be somewhere around here. Okay, so here it is around mm, the gain is around 98 millivolt, and the input itself is 100 millivolt. So obviously it's less than that, and we are getting very close to 100. We are getting a gain of 0.988. Okay, here right now, if you see over here, we are getting 98.88 divided by the 100 millivolt of the input signal. So we should get a gain of around 0.988. Okay, it's just close to 1. So that's the unique feature of this common collector configuration, and the input and output are in phase with each other. As you can see, they are not at all out of phase. Now let me just check this out. Yeah, it's all done. So I think that's it for this comparison between the three BJT amplifier configurations. Okay. Okay. So next time we'll see the comparison for the MOSFET amplifier configuration. So until then, have a good day and thank you.